Good morning, students. Let us discuss some questions from the chapter Biomolecules. When it comes to the first one, select the most appropriate functions done by the living system. Most appropriate function of living system means living system grows, sustains and reproduces. Living system grows, sustains and reproduces. So all the three are associated with the living system. So answer will be all of these. When it comes to the next question, a living system is composed of non-living dash. Choose the appropriate words in order to complete the above statement. So this is a basic line. Living system is composed of non-living atoms as well as molecules. They are not living. They are non-living atoms or molecules. So answer will be both A and B. Select the biomolecules that help during the formation of living system. During the formation of living system, all these carbohydrates, nucleic acids and lipids, every one of these biomolecules helps in the formation of a living system. So answer will be all of the above. And when it comes to the next question, which one of the following pairs is the essential constituent of our food? Nucleic acids and lipids are not essential constituents, whereas proteins and carbohydrates can be taken as essential constituents. So this may be the answer. Proteins and nucleic acid. Here again nucleic acids doesn't come under essential constituents and lipids also doesn't come under. So the suitable answer for this is proteins and carbohydrates. When it comes to the next question, which of the following statements are incorrect about the living system? First one is, living system is composed of living atoms and molecules. Already we discussed this point. Living system is composed of non-living atoms and molecules. So definitely first one will be the incorrect line. That may be the answer. Let us see the rest of the lines. Living system is made of complex biomolecules. Exactly correct. Biomolecules interact with each other in the living system, exactly, and simple molecules also plays an important role in the function of organisms. So B, C, D and are exactly suitable, whereas living system is not composed of living atoms and molecules. They are composed of non-living atoms and molecules. So the answer will be the first option. When it comes to the next question, biomolecules, three statements are given. Select the correct option for the choices given below. So which are the correct sequences? See, first line is biomolecules are carbohydrates, proteins, nucleic acids and lipids, of course. So along with vitamins. Biomolecules are the organic compounds. Obviously they are all organic compounds, and plants and animals are made up of biomolecules. So all the statements are correct. So the correct answer is 1, 2 and 3. Next question is, which of the following statements are false about carbohydrates? See, it has a general formula CxH2O taken Y. Because of this reason, as they contain carbon and water molecules, earlier these compounds were named as carbohydrates, hydrated carbon compounds, like that. So first option is correct. CxH2O taken Y. This was the general formula given for carbohydrates. So first one is correct. They are hydrates of carbon, exactly the same line what we discussed. Even second is also correct. And third line is the molecular formula of glucose is C6H6O6 and general formula is C6OH taken 6. No, glucose molecular formula is C6H12O6. Glucose molecular formula is C6H12O6, you are aware of. So third one is an incorrect line. So choose the correct option means which of the following statements are false about carbohydrates? So only third line is the false line. Now let's come to the next question. Assertion reason model. Acetic acid is a carbohydrate. How can we say acetic acid is not a carbohydrate? See, reason is given as acetic acid fits into the general formula C2H2O taken twice. It is CH3COOH. When you add all these atoms, C2H4O2. So formula may fit into this acetic acid formula, may fit into this general formula, which is similar to the carbohydrates, CX H2O taken X or Y, like that. But acetic acid is not at all treated as a carbohydrate, right? So we can say assertion is wrong, and the reason is correct line. Let's come to the next question. Glucose, fructose and ribose are the common examples of monosaccharides or oligosaccharides, carbohydrates, or both A and C. See, glucose, fructose and ribose are the common examples of monosaccharides. Monosaccharides means those carbohydrates which cannot be further divided into simpler carbohydrates on hydrolysis. So glucose, fructose and ribose, basically they are carbohydrates and comes under monosaccharides. So best example for this is both A and C. And when it comes to the next question, carbohydrate that yields dash number of monosaccharide units on hydrolysis are called as oligosaccharide. Monosaccharide means which cannot be further hydrolyzed into simple carbohydrate is monosaccharide, which can be hydrolyzed to give 2 to 10 simple carbohydrate units are called as oligosaccharides, and which give large number of monosaccharide units or carbohydrate units on hydrolysis is called as polysaccharide. So the correct option for this oligosaccharide is 2 to 10. When it comes to the next question, find out the correct option among the following statements. In reducing sugars, aldehydic and ketonic groups are free bonded. See, usually students concentrate till there only. In reducing sugars, aldehydic, ketonic, if it is given up to free, then that line will be 100% correct line. But what's continued here? Freely bonded. They should not be bonded. Aldehydic and ketonic groups should not be bonded. They should be free. So in that sense, in reducing sugar, aldehydic, ketonic groups, as they should be free without any bonds, but here it is given as free bonded. This is an incorrect line. So we should be very careful while such presentation in the paper. Next, maltose and lactose are non-reducing sugars. No, they are basically reducing sugars because of having free functional groups. The corresponding carbonyl group, aldehydes are ketones, as they are free without any bonds there, they are reducing sugars. So what are reducing sugars which can reduce Fehilling's and Tollens reagents? Fehilling's and Tollens reagents are non-reducing sugar. No, this line itself is wrong. Okay, first of all, they are not sugars. Next line is, so maltose and lactose are non-reducing sugar is the wrong line. Fehilling's solution, this itself is wrong. All monosaccharides, whether aldoses or ketoses, are reducing sugar because of having free aldehydic or ketonic group. So this is a correct option for the given question. When it comes to the next question, glucose occurs freely in nature. This is the first point. Glucose occur in the combined form. Glucose present in sweet fruits and honey, and ripened grapes contains glucose in large amounts. So what are select the correct statements and choose the most appropriate option. This is the question given. Glucose occurs freely in nature. 100% correct. It occurs freely in nature. And glucose occurs in the combined form. Yes, this is also correct. And glucose is present in sweet fruits and honey. And also ripened grapes contains glucose in large amounts. So as per these options, the correct statements and appropriate option means 1, 2, 3 and 4. Choose the appropriate statements about glucose. It is also called as a dextrose. Of course, it is also glucose has other name dextrose, and it is a monomer of the compound containing starch and cellulose. Yes, in starch and cellulose, glucose is the monomer, and its molecular formula is C6H12O6. So all the three lines are correct. So correct option for this is all of the above. And when it comes to the next question, what is the structure of glucose? What is the structure of glucose? This is the next question. See, when it comes to the glucose, glucose is an aldohexose. Glucose is an aldohexose, means it contains aldehydes, and hexose means a 6 carbon chain is there, and it contains 5 OH groups because on acylation, pentacetate formation is observed. So there are 5 alcohol groups. So this is the structure of glucose. So one terminal is aldehyde, other terminal is primary alcohol. So aldehyde and primary alcohol should be there. In between 4 chiral carbons, CHOH units should be present. So CHO, CH2OH, but here 2 chiral carbons are there. This is not the correct answer. CHO and CH2OH between 4 CHOH units. So second option will be the answer. And this is given 6 and that is given 1. So answer for this given question is second option. Comes to the next question. Match the following column 1 with the product given in column 2. Match the following column 1 with the product given in column 2 and select the correct option from the codes given below. So first one is it is a glucose molecule given CHO, CHOH taken 4 times and CH2OH. Glucose molecule when treated with NH2OH, hydroxylamine. See, actually it is elimination, addition followed by elimination reaction. So elimination of water molecule gives a CH double bond NOH, CHOH taken 4 times and CH2OH. This is an oxime. An oxime will be formed which is a property of aldehyde functional group. So where is the formation of oxime? So A maps for the second molecule. Similarly, what is the next one? Next one also given about glucose when added with the HCN. It is a property, addition phenomena shown by aldehydes and ketones. When aldehydes or ketones are added with hydrogen cyanide, because of this polarity H plus is grabbed by oxygen cyanide, attacks as a nucleophile at the electrophilic center, giving CN, H and OH. CHOH taken 4 times CH2OH. This stands for cyanohydrin. Glucose cyanohydrin will be formed. So where is cyanohydrin in this? So for this cyanohydrin, this is cyanohydrin. This itself is CH, CN, OH. CH, CN and OH. And obviously the next one is bromine water is nothing but mild oxidation. Bromine water oxidizes this aldehydic terminal to carboxylic acid. So this is the one. We have another oxidation in presence of nitric acid that gives saccharic acid. Saccharic acid means even terminal alcohol also will be converted to COOH. That is a stronger oxidant, whereas bromine water is a mild oxidant. So for C, it is option 1. So A maps to 2, B maps to 3 and C maps to 1. So the suitable option is C. Another important area is the relative configuration of the molecules. What does capital D and the positive sign signifies in D plus glucose? So usually glucose is given in this form, D plus glucose. So the point for relative configuration is relative configuration. In this, the first point to be noted is most oxidized carbon to be at the top of vertical chain. In giving Fischer projections, this is the first point one has to notice. Most oxidized carbon should be at the top of the vertical chain. Like in glucose, aldehyde is at the top. In glyceraldehyde also aldehyde is at the top. Suppose this is one form of glyceraldehyde. So one isomeric structure of glyceraldehyde. Next is in assigning capital D, capital L, the point is in highly numbered chiral carbon or on a highly numbered chiral carbon, if OH is on right side in Fischer projection, it is said to be capital D, whereas if OH is on left side of in Fischer projection, it is said to be capital L. The point to be noted is there is no relation between dextro-levorotatory the phenomena and capital D, capital. This is just a relative phenomena. And students, they are in a confusion like when to give D, when to give L. See, this is the first carbon, this is second, this is 3. And out of this only one chiral carbon is there. No way, we can easily answer. And on this chiral carbon, OH is on the right side. So capital D. So it is called as D-glyceraldehyde. It can be called as a D-glyceraldehyde. Next, the dextro-levo-rotatory nature is with respect to the experimental fact whether it can rotate optical activity or not. Okay. And now, so what are the options given here? D represents conformation and plus represents the levo-rotatory. There it fails. Plus is dextro-rotatory. D represents configuration. This is correct. And plus represent the dextro-rotatory nature. So this may be the answer. Let us see all options. D represents conformation, again failed. Plus represents the dextro-rotatory. Second line is correct, but first one is again wrong. D represents configuration and plus represents levo. So in one or other line, these two options are failed. So only answer is second option. Next, a similar question. Which of the following statement is false about the given structure? This is that of glyceraldehyde and its enantiomeric form. See, these two are non-superimposable mirror images. So they exist as enantiomers or enantiomeric pair. Now, when it comes to the options about these two structures, see, this is a chiral carbon. Of course, this is highly numbered chiral carbon also, for which OH is on the right side. So it is capital D glyceraldehyde. And this is also chiral carbon, for which OH is on the left side, capital L glyceraldehyde. So these are the isomers of glyceraldehyde, correct. This line is correct. Both contain one asymmetric carbon atom, correct. Both exist in two enantiomeric forms, yes, obviously, this is also correct. One refers to levoglyceraldehyde. How can we say? That is based on experimental fact and said to have capital L configuration. There it went wrong. One is of D configuration, two is of dextroglyceraldehyde and said to have D configuration. No, we cannot assign like that. Moreover, this is of L configuration. So the false line among the given are fourth option. So this is the answer. Next one is select the false statement about the cyclic glucose. Cyclic form of glucose, Haworth projection or pyranose structure. See, if this is the structure of glucose, C double bond OH, now there is a bond formation, glycosidic link. See, here it is, if this proton is transferred to this, then there is a possibility in two ways. If this is OH and this is the way they are connected, when OH is on the right side, it is called as alpha D glucose. When OH is on the right side, it is called as alpha D glucose. Now, while projecting this, you should know the projection also. You keep this oxygen as it is. Suppose you consider this oxygen here. Keep this oxygen as it is and project this chain front side of the board, so that all the right-handed groups are coming below the plane, all left-handed groups are coming above the plane. Then in such a case, so all right-handed groups, this is C1, 2, 3, 4, 5, 6. Now, on C1, this is C1, when it is flipped front side of the board, these all right-handed groups will come below the plane. So OH and again OH and this H and this is OH. And in Fisher projection, the vertical top end groups are to be assumed as the one projected away from the observer. Suppose you see the direction of these two fingers, vertical top and vertical bottom of the Fisher projection to be assumed as behind the board, whereas horizontal groups must be assumed as the one projected towards the observer. So as this is assumed as the one projected away from the observer, when you flip this chain down, this CH2OH will come above the plane. So this CH2OH is above the plane, obviously H comes below the plane. So these are the projections. Now, if OH group is added to the CHO, it forms a cyclic hemiacetal structure. Of course, it has formed. So first line is correct. And glucose forms a six-membered ring in which OH is at C5 position. Glucose form a six-membered ring in which OH group is at C5. This is 1, 2, 3, 4, 5. 5. See, glucose form a six-membered ring in which OH is at C5 position. C5 means means this is fifth carbon, it has CH2OH. And melting point of glucose is 423 and beta D glucose is 419. I think it's given in reverse way. Alpha D glucose is 419 Kelvin and beta D glucose is 423 Kelvin. So when it comes to see the melting point, this is with respect to the data given in NCERT during muta rotation concept. With respect to muta rotation concept. And fourth one is when OH is on the right side, that is called as alpha D glucose, just now we discussed, and OH is on the left side, that is beta D glucose. This is correct. So option D is correct, option 1 is correct. Glucose forms a 6-membered ring in which OH is at C5 position. That OH with OH, I think it is this is a wrong type, in which with OH at C5 position. So 6-membered ring is formed with OH at C5 position. So in that meaning this is also correct. So then the false line about this is melting point. So this is with OH at C5 position, with OH at C5 position the 6-membered ring is formed in that sense. And the false line is melting point of alpha D glucose is 419 and beta D glucose is 423. It's given reverse, so false line is third option. Now the two cyclic hemiacetal forms of glucose means alpha D glucose and beta D glucose. Alpha D glucose and beta D glucose. So one should be very perfect in these cyclic pyranose structures. So in alpha D glucose, OH will be projected down at C1 and in beta D glucose, OH is projected above the plane. Right. Now let's read the line. The two cyclic hemiacetal forms of glucose differ only in the configuration of OH groups at C1. That C1 is called as that C1 carbon is called as anomeric. Ano sounds uno means one, uno, ano is derived from uno means one actually. Okay, and like this isomers which differ at the configuration of first carbon are called as anomers. Other than first, any carbon in general called as epimers. So for this question it is anomeric carbon. And when it comes to the next question, 44th one, alpha and beta form of glucose are alpha and beta form, alpha D glucose and beta D glucose are at equilibrium with one another. We studied that in muta rotation also. At equilibrium they are anomers, just now we studied, and they are obviously cyclic in structures. So all of these. Next question, identify alpha D fructofuranose and beta D fructofuranose from the following structures. You know, actually identifying these cyclic structures is very important in predicting the link. Suppose if a question is given on sucrose, what are the links between so and so molecules, then we should identify by looking at these diagrams. One has to practice them like anything. Identify alpha D fructose. See, alpha D fructose means if OH is on the right side, that is alpha D fructose, and when you flip this molecule front side of the board, all right handed groups will come below. OH, H, OH, OH, H and OH, and this will go above the plane because as per the Fisher's rule projection, the vertical top and bottom are projected behind the board, so that will come above the plane. So H comes below the plane, and then it is connected to oxygen. So then it is connected to oxygen. So CH2OH is above the plane. So this is for alpha D fructofuranose. This is for alpha D fructofuranose, and this is also alpha D fructofuranose. And as OH is on the right side, it is beta D fructofuranose. Even this is also, when let us see whether it is same or not. When the carbon chain is projected front side of the board, all right handed groups comes below the plane. CH2OH, H, OH, and this H will be down, and CH2OH is above the plane, and OH, OH, H, OH, OH, H. So this is an exact projection of a beta D fructofuranose. So this is also beta D fructofuranose. For furanose structure of fructose, we can remember it in one way. OH is projected down in the structure means alpha, OH is projected up in the structure means that is beta. Now identify alpha D fructofuranose and beta D fructofuranose from the following means. This first one and third one corresponds to, let us see the options. First one and third one, first diagram and third diagram corresponds to alpha D fructofuranose. So alpha D fructofuranose first and third. So this one is matching. and second and fourth are matching for beta D fructofuranols. So option answer for this is second option. So next question, identify the monosaccharide units in the given structure. This is what I said. When a question is given in this way, we should be in a position to identify. This one is in the cyclic pyranose structure, OH is down below the plane. OH is below the plane, which had formed a glycosidic link. As OH is below, it is alpha D glucose structure. Alpha D glucose. And no doubt we can say this is a fructofuranols structure. But just now we did one question before this. If CH2OH groups, both the CH2OH groups are above the plane like this, that stands for alpha D fructose, alpha D fructofuranols. If one CH2OH and other CH2OH are in opposite directions like this, see CH2OH and say this is beta D fructose. And moreover, this is a glycosidic link between this one C1 and C2, between alpha D glucose and beta D fructose. So this is beta D fructofuranols. So one is alpha D fructofuranols, one is alpha D glucose, alpha D glucose. Alpha D glucose means, where is that alpha D glucose? This is alpha D glucose, and 2 is beta D fructose. So first option. When it comes to a question from proteins, fill up the blanks with appropriate words. So glycine, it's a characteristic feature inside of the chain, SH, correct? And a 3-letter symbol is what? Okay, glycine, GLY. Here the 3-letter symbol is GLY glycine, 1-letter code is G, correct? And for this, actually we can suppose if this is a basic amino acid, and if G is H, that is glycine, GLY, G is the symbol. If it is methyl, in place of G, if methyl group is there, then alanine, 3-letter symbol is ALA. And if it is isopropyl, instead of G, if it is isopropyl like this, that is valine, so VAL. And if it is a secondary butyl, thing, leucine, LEUL, like this. We have to remember the list of amino acids. Now for methyl branch, it is alanine. So for this it is alanine. It is alanine, correct? Alanine symbol is A. And valine, for valine it is the second isopropyl. For valine it is isopropyl, this one. Isopropyl. And the next one is what? Next one is leucine, secondary butyl. Yes, leucine. Leucine means secondary butyl is there, and its symbol is L. Now what are the options? First one is alanine, and the second one is isopropyl. Alanine, this is ethyl, this is isopropyl, and the third one is 3-letter symbol is GLY. So this is the answer. So obviously fourth one is the answer, because fourth one is L. Already we named that. When it comes to this next question, see, these two diagrams are given. See, about these diagrams, we can see these are parallel chains and alpha helix structure. So what are the points given about this structure? See, what are the points? This is alpha helix structure of protein, and this is a beta pleated structure. Beta pleated means where the side by side chains with hydrogen bonds between NH of one chain and CO of another chain. Hydrogen bonds are between NH of one chain and COO of another chain. Whereas in alpha, this is beta pleated structure. When it comes to alpha helix structure, so it is coiled in a right-handed screw model where hydrogen bonds are possible between NH and CO of the same protein. Okay, same protein chain. Now let us see what's given in this question. What are the options given about this? The options are, suppose if you observe this table, alpha helix structure of protein, 1 stands for alpha helix structure of protein, correct? And 2 stands for beta pleated structure of protein. So as per the discussion we had now, option 1 is suitable. Let us see the rest of the option. Alpha helix structure of DNA we cannot say, because DNA is a double stranded structure. It is a single line. So beta pleated structure of protein, no, wrong option. Alpha helix structure of protein correct. Beta pleated structure of DNA wrong. So option suitable for this is first option. When it comes to the question on enzymes, activation assertion reason model is given. Activation energy for the acid catalyzed hydrolysis of sucrose is 6.22 kilojoules per mole, whereas the activation energy is only 2.15 kilojoules per mole when hydrolysis is carried out by the enzyme sucrase. So, right, correct. It is this line is correct. Enzymes are associated with less activation energy, highly specific in nature, works at moderate temperature, small amount of enzyme is enough. We all studied these properties of enzyme in enzyme catalysis. Reason is enzymes, the biocatalyst, reduce the magnitude of activation energy. Very good, nice line. By providing the alternative path, correct. In the hydrolysis of sucrose, the enzyme sucrase reduces the activation energy. So both A and R are true, and R is a correct explanation of A. When it comes to the next question on purine and pyrimidine bases from nucleic acids, which of the following are purine bases? See, purine bases are adenine and guanine. Adenine and guanine. Whereas pyrimidine bases are cytosine, thymine and uracil. Cytosine, thymine and uracil. So these three are pyrimidine bases, whereas the purine bases are adenine and guanine. So 1 and 2 comes under purine bases. So 1 and 2. Next, when it comes to the next question, what will be the sequence of complementary strand of DNA if one strand of DNA has the sequence? Nice question. This comes under genetic code. See, genetic code means we have the complementary strand of DNA is A with T and G with C. The complementary strand in DNA is A with T and G with C. So for this, TATGACTG. So substitute 1 with the complementary strand. So T is replaced with A with T, T with A, G with C, A with T, C with G, and T with A, G with C. So ATACTGAC. ATACTGAC. So the sequence of complementary strand of DNA for the given sequence is option 3.